Assalamualaikum and salam sejahtera, Doctor. In this video, my friends and I would like to explain about our project. We have decided to create a bridge in Pahang, Selangor. But first, let us introduce ourselves.
Assalamualaikum. My name is Muhammad Hakim bin Muhammad Jinnah and my matric number is CN200196.
Hi, my name is Sharifah Adrianism Said Muhammad Ridwan and my metric number is CN200075.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Naimah binti Kasroni and my matrix number is CN200174.
Hello everyone, my name is Nuri Nadia binti Ashar with matric number AN200223.
My name is Muhammad Akmal bin Muhammad Nizam and my matric number is CN200258.
For this project, we decide to use river that locate at Kampung Kuala Medang, Pahang, which is called as Sungai Jelai, to create our new bridge design. For your information, the Pahang River covers almost all districts in Pahang, including Sungai Jelai itself. Pahang River, or in Malay we call as Sungai Pahang, is a river that flows through the state of Pahang, Malaysia. With a length of 459 kilometers, it is the longest river in Malaysia. The flow of the river starts from Tanah Tinggi, Cameron, next to Kuala Pahang, and then its end to South China Sea, or in Malay we call as Laut Cina Selatan. Originally, distance between the village and town of Kuala Medang to the old bridge is about 1.54 kilometers. So, the distance between village and town of Kuala Medang to our new bridge is about 992 meters only. These are few shots of scenery at Sungai Jelai.
In this project, we discovered a new issues regarding the problems occurred to the existing bridge. Firstly, traffic congestion often occurs as the school is built near the bridge, which is SK Kuala Medang. In addition, there is also the Kuala Medang Daytown site. It's a gathering place for the community there. The situation at peak hours is a concern with the increase in vehicles such as school bus, cars and motorcycles that gather to pick up students, as well as economic activities that take place at the town day site. The construction of new bridge will provide other alternative to road users and can prevent congestion and also accident. Besides that, this river is usually associated with two phenomena, namely river flood and flash flood. The devastating and unusual flood that frequently hit the east coast area have caused Kelantan to be severely affected, as well several districts in Pahang and Terengganu. The construction of this new bridge can be an initial preparation in the event of a major flood and cause significant damage to the original bridge. If that happens, this new bridge will be another alternative way to connect the two areas. There are several actions taken for the new bridge. First, build a closer bridge near the residence area without having to turn too far for the main bridge. Then, light vehicles are only allowed to use the new bridge when it's not flood season. Then, third, the bridge is built a bit further from the main bridge and built in higher areas. Prohibit heavy vehicle from crossing the new bridge to ensure the safety of user. 5. The new bridge to be built will be able to reduce traffic jam.
Okay, today I want to share to you about concept of bridge. A bridge is a construction of wood, iron, concrete and other that serve to connect two places separated by another buildings or structure such as river, streets, roads, railway, and so on, without covering the construction and the pad below. Okay, this is functions of bridge. The bridge is not only for the crossing of vehicle and pedestrians, but also used to house some another service such as pipelines, automobile and trucks, like rail and heavy rails, and lastly is for electrical supply. Okay, this is the example of bridge, which is a prod truss.
Okay, now I will explain about our bridge design. In this bridge design, we have used prod truss, which is the most strongest truss compared to Howe and Warren truss. The common materials used for truss are usually timber, iron, steel, reinforced concrete, and pre-stressed concrete. And as for the live load, the bridge carries pedestrians, automobiles such as cars and trucks, and any other heavy vehicles. For the dead loads, the bridge carries its own weight of truss components, pipelines, and more. Here are the advantages of using prod truss design. Firstly, the design is extremely strong. Secondly, it uses materials effectively. It is also common as it is a well-accepted and used design. Prod truss design can also withstand extreme conditions. And lastly, roadways can easily be built onto structures. By using prod truss design, there are also disadvantages which requires a lot of space. It is also have a high maintenance cost, and what concerns us that the number of truss are a lot that can make the bridge too heavy. Now this is our entire bridge drawing. This bridge has 4 spans and each span has 6 parts of joints where the trusses are connected. We have put a pin support at A and a roller support at L. The total number of members are 21. And every joint of trusses we have labeled all letter followed by A, B, C until L.
For my part, I will explain about the bridge calculation. For this calculation, will be calculate about the moment and the each part of the truss. As you can see, the beam is length with 24 meter and the full load included load and live load is 2000 kN. For the next slide, I will show how we get the max load and the moment of beam. How we get a max load is we put a truck weighing 25 tons on the bridge and its length is 14 meter. We estimate that 7 trucks of 45 tons can be taken on this 96 meter long bridge at a time. We multiply the 7 trucks by 25 tons and we get 196 tons. Convert the ton to kilonewton and we get 1940 kilonewton. After that, we divide the value into 4 lengths to get the total weight of the 96 meter of the bridge. But we just need to count one part of the bridge only and we multiply it by 4 parts of the truss because our truss has 4 parts and get 2000 kN for one part bridge. Each truss has 6 parts. The value we divide by 6 and we get the total weight for one part of the bridge is 313 kN. To calculate the moment, we'll multiply the total load which is 2000 kN with the beam length which is 24 meter and the total is 48,000 kN. The total by its subtract by the total weight of the whole which is 48,000 kN minus 24,000 kN and get 24,000 kN to get the y. Now, I will explain the calculation on each truss member. The angle I set for this through bridge is 15.5 for the same angle as AB and 32.5 for the same angle as BK. First of all, to find the sum of AB, the total load will be divided by an angle of 313 divided sin 57.5 and get 391 kN for the load in AB. All load for the same bar truss will be the same load as BK, CJ, EJ, FI and FG. For the AL load in AB, which is 391, will be multiplied with cos 57.5 to get 210 kN for the AL truss. Next, for BK truss, it is same with the AB truss, which is we need to divide the load 313 kN divided cos 32.5 and we'll get the 391 kN for BK truss. For the BC truss, the load of AL will minus with AL truss, which is 210 minus 391 sine 32.5 because the angle to x-axis, and we get the total load for BC is 420 kN. For the CJ truss, its calculation just same with the BK truss calculation. For the load in KJ truss, the total of AL and LK will be 8 because KJ truss accommodates the load of these two truss and load for KJ is 420 kN. Lastly, for the CD truss, the total of KJ load will minus with the CJ total load, which is 420 kN minus with 391 kN sine 32.5 and the total load will get 613 kN for the CD truss. The total load of DE, EF, FG, GH, HI, IJ, EJ and FI just same with the all calculation because they have same load and the same angle.
Okay, lastly is a conclusion. In a conclusion, this project has allowed us to understand about load distribution in a structure, such as about load, section and joint. It is because truss structure are considered to be one of the most useful structure in our daily life, such as for a bridge, tower, roof and so on. This truss structure also has become fruitful both in stability consideration as well. That's all for us. Thank you.